All right. Good morning, good evening, good afternoon to you all. My name is Gloria. I'm here with the Get Coin team, and I wanted to kind of go over a little bit of housekeeping before we get started with our sessions. Today's session is going to be an introduction to PyTeal on Algorand, and I'm here with Panjol and from the Algorand Foundation. And before they get started, we'll just take care of housekeeping. First and foremost, this session is recorded, so this session will be found um, along with all the other sessions on the Algorand Greenhouse Hack 2 playlist on the Getcoin Media YouTube page. There should be a playlist just mentioned with that has all the sessions. Second of all is if you do have any questions, you can throw them in the chat or in the Q&A. I'll go ahead and monitor both of them to make sure that your question get answered. Last and not least, feel free to tell us a little bit more about yourself. Say hi in the chat. Let us know where you are and what you're working on. It's a good way for us to get to know all of y'all, but it's a good way for all of y'all to get to know one another. And with that, I'll hand it over to Pranal, and we'll get started.
Thank you, Gloria, for the introduction. I would like to welcome everyone for the session. In this session we'll be going over a basic introduction about PyTeal, and why we do things on PyTeal that we do. What are the different aspects of this language, and how does it helps us to build smart contracts for Algorand. But yeah, before I start, I would like to ask you guys, what's your experience of building smart contracts? Are you familiar with Solidity? Are you familiar with PyTeal? Have you built something in the past so that I have some idea about the audience? So just feel free to type it in the chat box. And while you guys do that, I will just give you a very small introduction about myself. So my name is Pranjal. I'm based in India, and I'm the DevRel for Asia Pacific region at Algorand Foundation. I've recently joined Algorand Foundation, and honestly, it's been amazing. I've got to learn so much. I've been working with amazing people, and yeah, this is something that I'm still learning. But yeah, happy to share whatever knowledge and insights I have, working and building so far. So just to give you a brief about the introduction, about the session, I will have different things that I've covered in these slides. It goes over from introduction to PyTeal, then understanding about PyTeal basics, sequence, bytint, states, control flow, and subroutines. These are like the broad topics that we're going to be discussing today. And while we do so, feel free to ask any questions that you might have. And at the same time, if you want to refer to PyTeal documentation, you can do that as well. So you can just search PyTeal documentation, and you'll get the link pyteal.readthedocs.io, where you'll find the whole documentation, where it's very easy to understand and very user friendly for you to learn the language as you build. Apart from this, I will highly encourage you to follow the Algo Edu GitHub page, which is this one. It is managed by another amazing DevRel that we have at Foundation, Joey. And yeah, we have different things which are related to smart contracts development, basics about layer one features that which are specific to Algorand. We have different information and slides about smart contracts, about PyTeal, about Teal, and we have a lot more which is going to come. About Beaker, which will be covered in the following sessions by Joey and Evert. So yeah, these are all the things that you can check out. It's a very important repository for us. And apart from that, Algorand DevRel GitHub page is also an amazing resource. I will just pull it up. DevRel, yeah. So if you guys have no experience of working on PyTeal before, you can check out uh, this page. Yeah, PyTeal course. Algorand DevRel repository, as you can say, the team itself is very helpful for you to learn different things. And PyTeal course is the It's a course that you can also find on YouTube. It's a small playlist of about 10 or 11 videos that you can watch and you can build along. We also go over a few example dApps that we build along the way. So again, it's a very great resource for you to just see. And yeah, links are included in this. You can just see the YouTube PyTeal course. Now, coming back to the session. Yeah, so about the intro to PyTeal on Algorand. Firstly, let's understand what is PyTeal, right? So you always need a language to sort of interact with the blockchain, right? And in case of smart contracts, you need some language to then process into bytecode, and then it's executed in a way which blockchain understands. And specifically for Algorand, it's PyTeal. I mean, you can code in Teal as well. Python is a library which helps us in converting those expressions into Teal. So yeah, you can see PyTeal is a library for writing smart contracts on Algorand. I've also added a small flowchart about the flow of this conversion from PyTeal expression to Teal source code. As I said, PyTeal is a package which is used to convert into Teal source code, and then we have the bytecode, and then we interact directly with the blockchain. So you can see this, this is how the whole flow works. So yeah, and many people might ask why it's a good way for us to write smart contracts, because Python is a widely accessible language. Python has a great open source community. There are a lot of contributors which are out there, and there are a lot of tools which are available for developers. For example, the IDs are much more stable. The syntax highlighting is much more it's much more accessible in terms of Python in general, and PyTeal, that makes PyTeal a very ideal choice for us to code in. So it's a very basic advantage that we have. Now, coming to the basics, what PyTeal expressions represent, they represent the abstract syntax tree that we have, which basically goes on to convert into bytecode. So basically, what it means is you are writing Python code to produce the Teal code, in a very basic language. You are not directly interacting with Teal. You are writing Python functions, Python expressions, and then converting into Teal code. Now, PyTeal objects we have to create expressions, and we can also build the syntax, the abstract syntax for the AST. Now, whenever we call and compile the Teal methods, then the AST converts into the source code, and then from there we sort of combine our smart contract. So this is the whole flow of this whole conversions and languages. Another small point I would like to add is, at any point we are not instantly executing the Python functions or commands. Like whenever we are, like for example, whenever we are saying, okay, teal underscore source equal to compile teal, whenever we are compiling this sort of function, we are not compiling it at the real time. Whenever it all gets executed in the runtime, and then it goes on to interact with the blockchain. Otherwise, it doesn't really happens on the fly, like you would think it will happen. Going on to the sequence, now it's a very important part of a smart contract for us. Specifically, we would like to return these values, and here we have written return sequence. And we use the seq function to stand basically it stands for sequence. And within that, as you can see in this example, we have the compile teal function as well. Compile teal is basically to convert the PyTeal expression into the teal program, as we said, right? And all the other methods, such as log or return, that we have used, like we have used return here, they also expect a PyTeal expression, right? So for this, we had to sort of use the compile teal here. Now, as I said, right, sequence just stands for sequence. It means a sequence of PyTeal expressions. Now, its arguments uh, are the expressions to include in the sequence. and you can do that either as a variable, or you can do that as the number of arguments, or you can even pass that as a single list. So these are different advantages for that. uh, and as we said, compile-tail expects a PyTeal expression. And what else is there? I don't think there is. Yeah, I think we can move on to the other one, which is byte and int. So there are two types in PyTeal. There is a byte and there is int. So it's pretty simple. It does not have a lot of clutter. There's just two basic types, and the examples for which I've written below, like I equal to int 5, x equal to bytes content, like you have used a string there. Then you can wrap integers, you can wrap strings, and whenever we put integers in, you wrap it in int, and then you have a PyTeal expression which is representing that value. So you can use these sort of variables as in your smart contracts anywhere you want to call them. Similarly here, you have passed it in a string. Now you have used byte array to have this constant to reference anywhere in your PyTeal program. Now, you might wonder if you have to do the conversions between these two types. We have these two features. You can say functions, the itop and the btoi, basically to convert the integer into bytes, and the vice versa, the byte into integers. So and I would just like to reference that again. Whenever we are, as I said, like whenever we are executing the code, it's not happening in the real time. It's going to happen in the runtime. Uh, it's not going to happen in the Python compiler time. So again, I would like to reference it here. Whenever we are making these conversions happen from integer to bytes or the bytes to integer, uh, these expressions are going to be built up in the runtime, and it's not going to happen in the Python compiler itself whenever you are putting these commands. So moving on, we have the transaction fields. So smart contracts have to be invoked by a specific application, and we have transaction types. These are the transactions that you can set field to describe input of your program. You use it many times, and to do any sort of computations, to access whatever information you have, that you can get, you use the transaction fields. Now, here I've put different examples of different transaction functions you can call. Sorry. So yeah, from the current transaction pool, you can use transaction.sender. You can obtain length of a particular array. You can use transaction.length, transaction.accounts.length. You can get transaction pool of a particular account using the account, and then you can reference the account number as an array, and then you can also index these group transactions at the same time. So that feature is also available for us. Now, the last two that I've written is the application underscore args, which basically means these are arguments to the application, and these two are also available for us again to get a particular argument and to get a particular length of that argument. uh, and yeah, so these are the current ones, and then we have transactions in the current atomic group. Now, if you don't know what does it mean, basically, algorithmic transactions are special, and you can basically tie more than one transaction together. So these can be part of a bigger transactions, like we can group 16 of them at once, and and we call them atomic group or atomic transactions. And basically, if one of them is succeeded, the whole pool gets executed. So it's a advantage for us to sort of club these whole transactions. And in that case, the functions for us are used as GTX and dot sender. Again, similarly, you can reference the account number, like I've used the account number 2. So it will fetch us the details for the second account, and it's very user friendly. That's the only difference, that we're going to be that we are going to be using the G transactions. Otherwise, the arguments are sort of similar, and there are more fields which are available as transaction fields. I think if you'll just go over in the documentation, you'll be able to see a lot more. But these are the main ones that I wanted to highlight, so I've included these. Now, moving on to the states. So there are basically two types of persistent states in an AVM. One is the global, and another one that we have is a local state. Uh, Now, there's a very clear difference, right? So, in a global state, we have one instance for every app, and at the local one, we have one instance for every user, which means for every opted-in account. As you know, you need a user to opt in for any kinds of transactions. So for that, we use the local states in most cases. Now, just to give you more context about global states, as I said, there can be only one instance per app, and one key value can be stored per application, and you can set those key values, and while you're setting up those key status, you can make it to active, and then you can read the values as well. That's why we have three different kind of functions here. We have the app.global put, which will basically initialize the whole thing, which will make the key status to active. Then we have the global get, which is to fetch the current status. If I'll just move it, so these two are the yeah. So these two are used to get the status of the key value, and then we can look up these key values. What's the supply, and then what's going to be returned to us. And then we also have the functions to delete these key values. That's why we have the two global del, to just delete these values. So in the global state, we have these three sort of main functions that we can do. Similarly, in the local state, we again have three main functions. First one is, as I said, is to put. Again, in this case, it will be local put, because yeah. So in this case, again, it's going to be local put, and as you can see, it will write a byte slice to the sender's account. Again, it's a similar line, but only for the unit 64. Sorry, unsigned integer 64 of the sender's address. Just another way to write it. We have used different type in this, and then similarly, we have the local get and local delete for checking the status, to fetch the values, and to also delete it, to delete the balance from the sender's account, to delete the balance of the transaction accounts, and to delete the role of the sender's account. So, whenever we are building different applications like an auctions application, or we are building a votings application where we are transferring these roles from different accounts to accounts, these are very useful for us to manipulate in that way. So yeah, broadly, what local state means is, instead of storing everything globally, we can store these key values locally, and these get stored for the as per every user, or you can say as per every account which is opted in. Because in the larger scale, because it's not really scalable to use global states all the time. You cannot really support infinite number of users on your dApp if you are using global state all the time, because there's only infinite number of accounts that you can have in terms of global. So that's where we use the local states, where we want to scale it up to infinite users. So that's one of the main difference between the two states. Yeah, as I said, in terms of writing these two down, the only difference is that there's an additional parameter which is mentioned here. Like in accounts, we can say for the first account, which just tells us what account we are dealing with, what specific account we're dealing with, because there can be multiple opted in accounts. So it helps us identify which account we're dealing with. Now, yeah, next will be the control flow. So basically, control flow or program flow means that there are different uh, different, you can say we have different powers to return uh, and approve a transaction, or we have the power to reject a transaction. And it happens very easily, like you can just reject or approve. And broadly speaking, approve will just approve the transaction and immediately exit the code, while reject will reject the transaction, and then it will exit the code. So it's pretty simple, pretty clear. um, and these are like the special commands that we use, that we may need tell the chain that once the program is successful, do we need to commit these changes on the chain or not. So we are using these to sort of control the flow of the programs. Once it's successful, then we can, if we want, we can approve and push it to the chain, or we can also reject it. And if there's any sort of vulnerabilities, if there are any security issues, anything like that. So that's the that's the main difference. And it's a special, it's a very special command that we have. So yeah, as I've said, return is the PyTeal expression to return the opt code. We talked about approve, we talked about reject. In these cases, programs will be exited by either sending in that transaction or not. In return, uh, we get to return the opt code. Now there are different conditional things that we can also introduce in our smart contracts. One of them is if condition. It's pretty standard. It's pretty similar to what we have in other languages. We can have an if else statement. We can have multiple if else's as well within our smart contracts. If you want to have if you want to include different conditional arguments. Similarly, in PyTeal, you can use like this. Uh, Here, if I'll just, this code got a bit out of syntax. Now you'll be able to understand properly what's happening. So as you can see here, the retains the we have the if statement for the particular expression to be true, and if it's and the if the if statement fails, then we have the expression is false. So it's a pretty standard one that we have in other languages as well. And as I said, we can have multiple if and else's, which is just like doing switch in any other language. Here we can use conditional. Uh, we can use a uh, COND conditions, which can be very useful for us, which is similar to switch of any other language. Now here you can see we have used the cond. Yeah. So again, similar to if, we have used the cond statement, and it will just check each and every condition individually. Whichever gets triggered, that particular output will be displayed. Um, and if the second condition is satisfied, we'll get the option B was selected. But if none of them is actually true, then we'll get a error as return, right? So it's also mentioned here, like we'll get an error back if none of the three statements are sort of true, which is similar to any other language which has a switch condition for us. So yeah, that's that. And apart from that, we have the subroutines. These are the functions that you can just put inside your larger Python functions. And what we do is we introduce uh, decorators for subroutines. and the code will be stored once, and every time you invoke it, it will essentially go to the same subroutine in the AVM, and will make use of that again and again. Now, another important point or advantage of subroutines is that recursions are allowed in subroutines. So we can have recursive functions within the subroutines, and because Python functions are very modular, we can have different functions within the larger Python functions. So it's another advantage for us. Now, subroutines can be created that accept ABI types, which can be done either as ABI type as arguments, or ABI types as return values. Both of them are also available for us. And basically, what we'll do is PyTeal will type check all the subroutine calls. It will ensure that the correct types are being passed, and once it is done, it will also return the values which were used correctly. So again, the ABI compatibility is also there with the subroutines. So yeah, that was about the presentation that I had. Just a brief overview about PyTeal, why we use it and all of that. If you want to connect, uh, on Discord, you can hop onto our Discord and you can ask any questions that you might have while you're development, while you're on your development journey. You can also join the Algorand forum, which is pretty active. A lot of developers post new use cases. If they have any questions, they always ask there. Now the presentation is done, but I'd also like to show you a very basic example from the PyTeal course, which I think which will be very useful for you guys if you actually go ahead and work with that parallelly. Uh, I'll just share my tab. So yeah, this is the one that I'm mentioning. You can always just go to the YouTube playlist. You can try to compile that yourself, and you can see how to work around with different PyTeal smart contracts. I'll just share my VS Code now, so that you have a little bit of idea about how do you go about coding your smart contract. So yeah, so this is the sandbox I have. I hope you guys have seen the development setup tutorials that we have done last week. Joey did one in English. I have done one in Hindi, and we also have a Spanish tutorial for that. So I'm not going to be going over the whole tutorial again, but I'll just show you a brief step. Like if I were to like just tell you very briefly, you will need Docker, which has to be installed on a computer. You will need an IDE like VS Code. We recommend VS Code, so you can have VS Code. And you will need the sandbox environment, which will have the indexers, and it will also set up a node for you to test your smart contracts, do some transactions. So my Docker is initializing, and yeah, it takes some time. It will just initialize. Meanwhile, uh, I will just change the directory to my sandbox folder. So current working directory, yeah, I'll just change it to sandbox. And how do you actually set up your sandbox? You just clone the Git repository that we have. Just clone it in your um, in one of the local paths, and then you just change the directory, and then we have a basic command to get the sandbox up and running. We have sandbox up. So yeah, as my Docker is sort of ready, I'll just give my command. I think it has already started running. I will just run the indexers as well. So I think there's some problem with the sandbox. But anyways, just to give you an idea about the setup, right? So along with that, you'll also need to add the volumes part in the algo D under the algo D services. You'll need to also add the volumes where you'll have to mention the path for your project, whichever you are compiling, so that you can compile your project with the particular sandbox. So you're also need to you're also supposed to do that, and yeah, and once it's done, you can just go ahead, just mention the path over there, and you can just have another project folder. Like I have the project folder. I have different smart contracts written in this, which are again from the YouTube tutorial. You can just compile these and you can check it yourself. Now, if I were to just see if it's running or not, I'll just write a very basic, simple smart contract. Um, I'll call it basic.py from PyTeal. Import star approval. I'll just explain to you in a bit what does all this mean, and the clear one, and we'll say return clear. So, so I'll just save that. So what happens is, basically, each stateful contract has two bits of teal code. One of them is approval function, and one of them is the clear function. And whenever, if you just go into the compile.py, what you can see is, it's taking these two outputs. It reads the two output files, approval out and clear out. It reads it into the module that we have. Uh, we have the PyTeal module. It will call the approval function. uh, it will call the approval function. It will return the values which are inside there, and it will also call the clear function. It will call the clear. It will call the uh, uh, it will call the clear transactions, and then it will read into the output files, and then uh, and we use the this file build.sh, sort of interact with the smart contract to build that particular file. So yeah, so that's great. You've got the sandbox running. I mean, that's probably the most complicated step that you have to go through to get your developer environment running. If I'll just check if this is working or not, if I would just build it, build.sh contacts dot counter dot basic. Yeah, I think because of the sandbox, it's getting some error. What I'll do is I'll set up the sandbox again then. Uh, yeah, I'll just, and I'll also show you guys how to do that. So just find the sandbox repository. It will literally take just seconds. Commit the session. I'll hit a new session. Yeah. So I'll say git clone. CD sandbox. So yeah, it will just initialize a new Docker container for us. So it's a very basic smart contract that I've written, right? So it will just give us the give us the values back, and you can just go through different smart contracts which are given in the course as well to understand how are you writing the global variables, how are you, in this case, we have used the byte slice, we have used the unsigned integers, and what's happening behind the hood, and you can make some changes. You can try it yourself if transactions are going through or not. So all of this is really user friendly for you to use as well. And yeah, I think this repository has pretty much everything that you will need. This one. Uh, oh yeah. Apart from that, I also wanted to mention the auction demo smart contract repository that we have. So you can also try to compile this auction smart contract yourself, which is basically which is not an auction of an ASA or an asset, and not an NFT. Uh, it's basically just competing for the same state, and it's a very very nice example that you can just try to compile it yourself. Um, although the requirements have been written here as well. It's pretty straightforward for you to again do that. So yeah, I think this was a very basic overview of all the things. Just stop sharing my screen. If you guys have any questions or concerns, you can just let me know. I'll mention all the repositories and presentations for you to sort of play around and just run it locally in your testnet.
All right. Thank you so much, Panjal. At this time, it would be great if you do have questions. Feel free to drop them in the chat or the Q&A, and we'll make sure that your questions get answered. It was a pretty concise little tutorial. Let's see. I don't know if anyone has any questions. I don't see any questions just yet. And I think most people were going along with you as you were going, as you were doing
Yeah,
this.
I mean, it's pretty easy to understand PyTeal and everything. If you guys want to just check out the documentation, this is the link. You can always find different functions. Um, and sorry, this this is the documentation link.
Awesome. And Punjal, are you in the Greenhouse Hacks Discord channel too? So if people do have questions, maybe reaching out there would be a good spot.
Yeah, I think I should be in there. You can just tag me if you have any questions, or you can just post your questions in general. I'll just make sure to hop on and just see, okay, if there's any concerns or problems that developers are facing.
Awesome. There is a question that just came up, and it says, "Is there any way to simulate transactions on all of them?"
Yeah, you can write a very basic simple smart contract, like the one which are there in the tutorial which is there about PyTeal. I think the first couple of uh, steps which are mentioned as couple of videos, I think you'll be able to do those transactions yourself, and you'll be able to see. Of course, these are
Awesome.
going to be on testnet. Yeah.
Yeah, for sure. And then there's one that says, "Can we use Python for coding?"
Yeah, absolutely. So, we use Python and we use PyTeal because it's very hard for developers to sometimes interact with Teal directly. So, whatever functions we are building, whatever code we are writing, it's only in Python. It's a very friendly Python package, and all the work is happening in the backend where it's automatically converting to Teal. And all you need to do is just write simple and very modular Python functions, which are available in the documentation. You can just go through that, and all the conversions and everything which are supposed to happen into Teal, that will be happening in the background. So this way, PyTeal is very user friendly, especially for the Python developers.
All right. I'll give you one more moment for questions. Perfect. Um, yeah, are you aware of meme pool on Ethereum, and is there anything similar to that on Algorand?
Yeah, so I'm aware about the meme pool on Ethereum. I think you still can't like there's very particular APIs that you can use to sort of access the meme pool transactions. Not sure exactly if I'm aware about the meme pool transactions Algorand, but yeah, I'm gonna research on that, and I can maybe look that up if we already have something like that, and that we can reference to get the meme pool transactions.
There's a question here too, and it just says, "Can you say the GitHub name to see the code?" So maybe if we could link the GitHub
Yeah, sure.
repo.
I will just share the link of these repositories. So under the contracts folder, you guys will be able to find the smart contracts that you can execute, and this is the auction DApp, which is there, to simulate a auction-like setting. Again, I don't think it's for any of the NFTs or an asset, but yeah, these are the two documentations that you can refer.
Awesome. Thank you
And
so much for sharing.
yeah, I
All
think
right.
that's it.
Yeah, I think that's it question wise. So, with that, I will just conclude today's session. Again, thank you so much, Panjal, for going through this with us and for introducing us to PyTeal. Hopefully, y'all will get a chance to explore it a little bit more and give it a try. Um, if not, you can refer again back to this video. It's recorded, and I'll share the link in the Discord once the video is uploaded. Again, Panjal,
Thank
thank you
you.
so much for your time. And
Thank you,
for
Gloria.
everyone
Thank you,
else, we'll
everyone.
see you again tomorrow. Yeah, Pranjal, any other closing words?
No, I mean, I just, if you guys have any questions, feel free to post it in Discord. Me or someone else can just take those questions. And, I've already given you these documentations and GitHub links, so you can just explore it yourself, and feel free to experiment and try it on yourself. And it's not that hard for you to understand PyTeal because Python is one of the simplest languages. It makes very easy for the developers to interact with our Algorand smart contracts. So of course you're gonna have a fun time while you learn PyTeal, and you learn as you go.
Awesome. Alrighty, y'all. I'm excited to see you put this to action and see what you guys come up with. Other than that, I will close this session and I'll see y'all tomorrow for our next session. Tomorrow's session is going to be, what is it? Oh, Introduction to Reach. It's
Yeah.
going to be happening tomorrow too. So, all right. I'll talk to you all later. I'll see you tomorrow for sure. Same time, same channel. All right. Thanks again,
Bye
Panjal.
everyone.
We'll talk to you soon.
Bye everyone.
Bye.